Dear student, welcome to all of you in my online math video class. Today we will discuss the next part 3. This is the part 3 video of our topic circle chapter number 15. Today we will discuss about the tangent and secant properties of the circle. In this topic we will discuss one theorem, and the theorem is that the tangent at any point of a circle and the radius through the point are perpendicular to each other. But before proving this, let us see the three conditions. That three condition is that if we have a circle, then how many possibility possible? Look here, we can make a line like this here. Here, line L is out of the circle. It means the line and the circle has no point which is common in both places. Okay. Again, in the second case, if we have a circle and we just it means here this is the line L. Here there is a point P which is common in both circle as well as the line. It means there is only one point P which is contact to the circle. Okay. Other point except P is not common in the circle. This time here P is called the point of contact. And in this case this line is called tangent. Okay, it means if we have a line which is in the form of tangent, then there will be at least one point which is common in circle as well as the line. The third case, if we have a circle, the next case may be like this. Here we have 2 points. This is P. This is P. Like this is P and this is P. And this is the line. It means there is 2 points which is P and Q is common in the circle. Okay. There is no any point other than P and Q which is common. So here the line L is called secant of the circle. Getting? It means there are 3 possibilities for circle and line. The first possibility, when L and means line and circle have no point of contact, means the line will be out of the circle. And the second condition, when L is like a means line is like the tangent, it means the line and the circle has one point of contact. In that case the line is called tangent. The third case, when the circle and the line has 2 points of contact, it means there are several points in the line, but in that several points we have only 2 points P and Q which is lie on the circle. Means on the boundary of the circle, it means the line cut the circle at 2 points P and Q. In this case, the line is called secant of the circle. Okay. Here the line L is a secant to the circle. Only these 3 cases is correct. Now, on this basis, we try to understand this theorem. According to this theorem, the statement of the theorem is the tangent at any point of a circle. Tangent at any point of a circle and the radius through the point are perpendicular to each other. Okay? It means that the tangent, what we see, we just take a circle and a line which is tangent. If this is tangent, it means it has a point which is common in circle as well as in the line. According to this, the radius through the point, this radius through the point, this is the point of contact. Okay, but the radius through the point are perpendicular to each other. Means the radius through the point and the line are perpendicular to each other. We have to prove this, that this line and this line are perpendicular. So what? We just write the given portion. We just have a circle whose center is O and a tangent L, line L, which is the tangent at a point P. This point is the point of contact. Okay, of the circle, and we have to prove that this OP, means this radius, is perpendicular to this line. We have to prove this, and for this we just make a construction so that we can prove it clearly. We just take a point which is take a point Q out other than P. We can take any point here, this side also, no problem. We just take a point Q other than Q on this line L. Okay. And after that we just join this line O and Q. If we see here, if we join the line O and Q, the line OQ, a line segment OQ, intersect with the circle at point R. Okay, so here take a point Q other than P on L and join OQ. Now how we prove? Since according to the construction we write here, since Q is a point on the tangent L, here line L is behaving like a tangent, therefore we use this word since Q is a point on the tangent. Okay, we can at the place of line L we can just write tangent L other than the point of contact P. Okay, other than the point of contact P. So Q lies outside the circle. It means here point P is lying on the boundary of the circle, means in the circle, means in the region of the circle. But here Q is just out of the circle. So here we can write here OQ. OQ, we know that this OQ from this to this is the sum of this OR and plus QR. OQ is the sum of OR plus QR. In this way, OQ is equal to OR plus RQ, RQR. It means that this OQ is greater than OR. Getting? It means this OQ is greater than OR. But we know that here OR and OP is the radii of the same circle. Then we can see here OQ is greater than OP. Why? Since OR is equal to OP. We can more explain, we can write something more, because OP and OR are the radii of the same circle. Get it? So in this way, we can also write here that the value of OP is less than OP. Okay, the value of OP is less than OP. The next stage, how we should write? In the next section we write in this way, the OP is what? OP, if we take any point here, we just consider for a second. If we take any point here, just like A, B, C, D, so all the point OA will be greater than OP, OB will be greater than OP, and every point, if we take any point, all the lines which joining the center of the circle, that will be greater than this OP. Okay, this OP, it means in a short we can say this OP is the shortest distance from the tangent. Okay, thus we can write thus OP is the shortest distance from the tangent. OP is the shortest distance from the tangent. Okay. So in this way, if OP is the shortest distance between the center and this, in that condition, finally we can write this implies that OP is perpendicular to L. Simply you can write. Okay. In book some more sentences are given. If you want to use that, you can use. But finally, if you do like this, you can also write. In this way, this statement is proved that if we take any point, the tangent at any point of a circle and the radius through the point are perpendicular to each other. In this way, you can solve, you can understand and practice this theorem using this concept. Okay, let us see one more theorem that is based on the tangent and circle. Dear student, let us see the new topic, that is number of tangents from a point to a circle. Number of tangents from a point to a circle. Here and after that, first of all we discuss the number of tangents from a point to a circle, and after that the second topic will be length of the tangent from a point to a circle. Okay, so first of all we should discuss about the first concept, number of tangents from a point to a circle. If we have a circle, there are three conditions. The first condition is that here, the first condition, if we have any point, we have any circle whose center is O, okay, and any point P in the circle, and if we draw a line which is passes through the point P, then it may be like this way. It may be like this way. This means whatever line we are just drawing here, all the lines intersect the circle at this point. Similarly, this point line at this point. Similarly, this line intersect at this point and this point. It means whatever line we draw through this point, the point which is inside the circle, that line by intersect the circle at 2 points. Okay, here you see that there is no line which is tangent. It means if a point is lying inside the circle, tangent is not possible. Okay, the second condition is what? The second condition, if we have a circle whose center is O and a point on the circle, means on the boundary of the circle, then one and only one tangent can be possible. Okay, and whose distance from the center is always 90 degree. This perpendicular. Okay, because the distance OP, the O and P is the shortest distance between the center of the circle and the point on the line. It means if the point is lying on the boundary of the circle, so from that point, one and only tangent is possible. Then, the third condition is that what happens if we have a point P outside the circle whose center is O. In that case, we can draw maximum 2 tangents from the point P, which is outside the circle. It means if the point is lying inside the circle, then no tangent is possible. If the point P lie on the circle, boundary of the circle, then one tangent is possible. If the point is lying outside the circle, then maximum 2 tangent is possible. Okay, then in which case tangent is not possible? It is only possible when the point is inside the circle. And if a point is outside the circle, then maximum how many tangent possible? It is 2. Okay, but if the point is inside the circle, so whatever line we will draw, the diagonal line, each line intersect the circle at 2 points. Okay, this is the concept. Now, the second thing whatever we want to discuss, that is the length of the tangent from the point to a circle. Let we have a circle with center O and a point P whose distance, okay, whose distance from where we just draw 2 tangent here. So here let this point A and this point B. Okay, if we draw just this distance AP and BP is known as length of the length of the tangent. Length of the tangents. Length of the tangents. It means the distance OP and BP is the tangent of the, is known as length of the tangent. Means AP and BP is what? Length of the tangents. Okay. If we are talking about the length of the tangents, it means simply it will be AP or BP. Let us see one theorem basically related of this concept. The theorem is that if two tangents are drawn from an external point to a circle, then what happens? In that case, the first one is tangent of the length of the tangent are equal. Length of the tangents are equal. And the second is what? The tangents subtend equal angle at the center. The tangent subtend equal angle at the center. It means, and the third one is that the tangents are equally inclined to the line joining the points and the center of the circle. Getting? Here, if two tangents, this point P is outside the circle. Here we have two tangents PA and PB. Okay, then first of all, we have to prove that PA is equal to PB. Means both tangent, length of the tangent are equal. Okay, the first one, PA is equal to PB means the length of the tangents are equal. And the second, the tangent subtend equal angles at the center. It means we have to prove that angle AOP means this angle, you have to prove that this angle is equal to this angle. Okay, here this is the geometrical concept of this segment. The tangent subtend equal angle at the center. This tangent subtend equal angle at the center. We have to prove this. And the third is the tangent are equally inclined to the line joining the points and the center of the circle. It means here we have to prove that OPA means this angle is equal to this angle. Okay, we have to prove these things. Okay, according to this statement. So first of all, we should write the given portion according to the statement. So what we write in the given portion? We write that P is an external point to a circle with a center O. Okay, P is the external point to the circle O. PA and PB is the tangent. PA and PB are two tangents from P to the circle. Okay, and A and B being point of contact. It means if PA and PB the tangent, in that case A and B is the common point on the boundary of the circle. In this way, with the help of you, you should write the given portion. Okay, and here this is the mathematical form of this statement. The lengths of the tangent are equal, means PA is equal to PB. The tangent subtend equal angle at the center. Then in that case, the mathematical form will be angle AOP is equal to angle DOP. And the third, tangents are equally inclined at the line joining the points and the center of the circle. Means we have to prove that OPA is equal to OPB. Okay, so how we prove? For this, just take two triangles. In triangle, we just take two triangles. In triangle OAP and triangle OBP. Therefore, we know that OA and OB are equal. Why? They are radii of the same circle. Okay, here OA is equal to OB. Why? Radii of same circle. Okay, radii of the same circle. Again, we can write that here the value of OP is common is come in both the triangle, in both triangle OAP, then also OP is the one side of triangle OAP, and in OBP also OP is the side. So here OP and OP is come. Now the third one is what? Here we know that the distance of a point of contact of a tangent and this center of the circle is always shortest distance, and the shortest distance is always perpendicular. It means this is 90 degree. Similarly, here this angle is also 90. And what is the reason behind this? The reason is that because the tangent at any point of a circle is perpendicular to the radius through the point of contact. Okay, so here we can write angle OAP is equal to angle OBP by each 90. Simple. Find here. Okay. Here. If you know the statement, you can write the statement. That will be the best. But it may be too far yet. So here you should write each 90 degree. How? Why it is? Because by here. Now, therefore, triangle OAP is congruent to triangle OBP by which rule? RHS. By RHS rule, or by RHS criteria of the congruency of two triangles. Just before it, here you can write by RHS criteria for the congruency of two triangles. Triangle OAP is congruent to triangle OBP. This implies that PA is equal to PB. Okay, bisecting rule. Corresponding part of congruent triangle is always congruent, we can write. And the second also, the first one and the second one is also angle AOP is equal to angle BOP, and the third one angle OPA is equal to angle OPB, and all these are possible due to CP. Okay, due to CP. Okay, in this way we can prove this three mathematical statement. Okay, and you should remember it. It is very useful for the coming exercise questions. Okay, in this way, in this video we will discuss only this much, and only one thing is left now, and that is angle in the alternate segment. Only one video now I will prepare to share you, and that will be the last video for your syllabus as well as for this topic, that is chapter number 15, circuit. Okay, so here it's your duty now to keep it the concept in your mind for solving the questions, and try to understand the example questions as well as the exercise question. The PDF I will try to share with you, and if you have the doubt, you should ask the WhatsApp group, whatever you have. Thank you.